Alright, hello guys, welcome to Brit and Joss Explains. My name is Joss and today I'm going to be explaining the parallelogram law for you guys. So the parallelogram law is used as an early concept in statics. So what is it exactly? It is a graphical method that is used to find the resultant force of two forces or more that come from the same point. So as you can see, I have my F1 and my F2, and they're coming right here from the same point. So why is it called the parallelogram law? I'm going to draw it out for you guys just so you guys can get a visual. So this is going to be my F1 force, and this right here is my F2 force. So what we're going to do is we're going to draw this out into a parallelogram, and the way that we're going to do that is we're going to start from this point. So we're going to start at the end of like the tip of the second force, and we're going to draw a line that is parallel to the F1 force. So we're going to start from here and draw up so that it is parallel to this line right here. And then we're going to do the same thing from this tip and draw a line that is parallel to this one until they meet and they intersect right there. And then this line right here that is going to go through both of them, this one is going to be our resultant force. So how do we calculate the resultant force from this visual? So as you can see here, I've written out the equation for when we have two forces and we want to find the resultant force. So all we're going to do to find r is we're going to take the square root of the first force squared plus the second force squared minus 2 f1 f2 cosine theta. So let me draw that out so we can see our parallelogram. So here's my f1, here's my f2, and then we're going to do the same thing as before where we're going to start at the end. We're going to start at the tip of this one and draw a line that is parallel to the other one. Same thing, start from the tip, parallel line until they intersect, and then this is going to be our resultant force. So as we can see here, we already have this information. So we know that F1 is 5, we know that F2 is 4. The only thing here that we would need to figure out is our theta angle. So which angle are we using for theta? So the theta in this case is going to be this opposite angle right here. So this is the one that we're looking for. And from what we know from just basic geometry and triangles, we know that a triangle, all of the angles inside is going to add up to 180 degrees. And from what we know about parallelograms, all of these angles are going to correspond with each other somehow. So if we're taking this angle right here, that this is 40 degrees. So we know right here is 40 degrees. I'm just going to draw a little arrow. And this one over here is 30 degrees. We know that these two angles correspond based on what we know about parallelograms. So this is going to be 30 degrees. And as I said, we know that all of the angles are going to add up to 180. So we're just going to subtract the ones that we know from 180 to get the other angle, which is going to be 110 degrees. So now that we have our theta, we can go ahead and plug in all of the values into the r equation so that we can find the magnitude of the resultant force. So let's go ahead and do that. So our F1 is 5 squared. F2 is going to be 4, square that, minus 2, F1, F2, cosine of 110. And that is going to give us a resultant of 7.39 kilonewtons. So that is the magnitude of our resultant force. So, given this, how would we find the angle of the resultant force? Because this is a vector quantity, so we need to know its magnitude and its direction. So how would we find its direction? All right, so to find the resultant angle, we're going to use something called sine law. So as you can see, I've put this little like diagram in this equation for you right here. So this states that this side A over the sine of its opposite angle is equal to the side B over the sine of its corresponding angle right here. And that's consistent with C and so forth. So what we're going to do is we want to find this angle right here, alpha. We're going to call that one angle alpha. So since this one we know is 4, this one is also going to be 4 over here. So we have this side 4, and we could use 5, or we could use the resultant one. I'm going to use the resultant one. So we have that as 7.39, and its opposite angle up here is 110 degrees like we had determined earlier. So I'm just going to set that up like this. So this, like C, so 7.39, and it's going to go over the sine of its corresponding angle. So sine of 110. And then we're going to use this one, since we're solving for this, 4 over the sine of alpha, which we don't know. So I'm just going to do a little bit of algebra to solve this. So first things first, we need to multiply 4 times sine of 110. We're going to multiply these two together. So sine of 110 is going to be 3.75. And then we need to divide by this number here, which is going to equal 0.5086. And then last but not least, we just need to take the sine inverse of that. Which is going to give us, with our angle, 30.57 degrees. Alright guys, so I just want to go over a problem from the textbook. This is example 230, and it states that if force FB is 3 kilonewtons and the angle theta is 45, we need to determine the magnitude of the resulting force of the two tugboats and its direction from the counterclockwise of the positive axis. Or clockwise of the positive axis. So it's pretty similar to the one we already did. So I'm just going to start by making our parallelogram. So we have our little box. We have our F1, which is 2, and our FA and FB, which is 3. So we're going to start by drawing our parallelogram. Same thing. Opposite end, parallel line, opposite end, parallel line. And then this middle line right here is going to be our resultant force. So we're going to use the same equation as before, where we have R equals the square root of f1 squared plus f2 squared minus 2f1 times f2 cosine theta. Alright, and we just need to find our angle theta for this equation. So what would this angle be? So again, we know that the whole triangle is going to add up to 180. And from our given information, we can determine what this is. So if this is 30, right here, this one is 30, and then this one right here that we're given is 45. This one is also going to be 45. So if we have 180 minus 30 plus 45, that's going to give us this angle theta is going to be 105 degrees. So now that we have that, we can plug in to our big equation here. So let's do f1, we know is 2 squared plus fb is 3 squared minus 2 times 2 times 3 cosine 105. And that is going to give us a resultant magnitude of 4.013 kilonewtons. Okay, so now that we have our magnitude, we're going to be able to determine our angle. So we have to use the sine law for this. So here's our triangle. And we want to know what this angle alpha is right here, which is the corresponding angle for this side. And since these ones are equal to each other, we know that it's 3. So this one is 3 because this one right here is 3, and they match. Same thing here. So this one's 2 and this one's 2. And we know that this resultant force that we just got right here, this one is 4.013. And we know its angle, which is 105 degrees. So we're going to set it up same way as we did before, where we have 3 over the sine of the unknown alpha is equal to the resultant force over its opposite angle, which is the sine of its opposite angle, which is sine of 105. So once we do all that algebra, we can find that our angle alpha is going to be equal to 46.22 degrees. But we want it to be measured clockwise from the positive x-axis, which means that we're gonna have to subtract 30 from this. So minus 30. So we're left with 16.2 degrees. Alright guys, that was the parallelogram law. Let me know if you guys have any questions, and thank you so much for watching.